Hello. So here we see another triangular rule. This is so quatre, okay, and which is what a lot of us here are familiar with. The so quatre. First of all, we see a right angle triangle again. So quatre is only applied in a right angle triangle. Okay, so you can see your angle here, theta. Then this is your box, which represents 90 degrees. Okay, the side facing the box is what we call the hypotenuse. The side facing the given angle here is theta. Theta is given, okay, that's opposite, while the other side is adjacent, okay? So when we say so quatre, so here means sine opposite hypotenuse. So that's how we have sine theta is opposite over hypotenuse. The same thing, C there is cosine adjacent then hypotenuse. That's why we say cos theta is adjacent over hypotenuse. The same thing with tan theta, which is OA, tan is opposite over adjacent, okay? That's the reason why we have what we have there. Now, we can also see by relationship that tan theta is sine theta over cos theta. That should not surprise us, okay? Because remember, if you say tan theta is equal to opposite over adjacent, is the same thing as saying opposite over hypotenuse, okay, times hypotenuse over adjacent, okay? It's the same thing as saying that. And okay, let me do something else. When you say tan theta is sine theta over cos theta, okay, your sine theta is already opposite over hypotenuse, while your cos theta is adjacent over hypotenuse, okay? So which means that opposite over hypotenuse now times hypotenuse all over adjacent. So you can see when hypotenuse cancels hypotenuse, you are going to now get opposite all over adjacent, which is our tan theta. Okay, so generally we should know that tan theta is sine theta over cos theta. Okay, so that leads us to the next thing here. Look at this question. We are given that in a right angle triangle, sine x is 3 over 5. Evaluate leaving the answer as a fraction. Okay, we are asked to leave the answer as a fraction. Okay, so when we say sine x, if you represent this in a right angle triangle, and this is my angle, and this is my right angle here, and this is my x here. Sine x means opposite over hypotenuse, meaning that your opposite here is 3 and your hypotenuse here is 5. So we don't know the adjacent, which you can call a. Now we can use Pythagoras theorem to find the value of a by saying that 5 squared is equal to 3 squared plus a squared, okay? So 5 squared is 25 is equal to 3 squared is 9. Your a, we have a squared, okay? So if we subtract 25 minus 9, it's going to give us that is going to give us 16, okay? So that means your a here is equal to 4. So our a is 4. So with this, we can find cos x, okay? So now cos x here, like we have here, is equal to, according to our definition, is supposed to be adjacent all over hypotenuse. Okay, so our adjacent here is, from what we just got now, is 4, which is our a is 4, then our hypotenuse is 5, okay? That's the value for cos x. Now, I want to say this. If you notice in this question, the angle was not specified because your x angle can either be acute angle or obtuse angle. I want to say this, that if you are dealing with an acute angle, okay, all the sine ratios are positive, okay? But if you are dealing with obtuse angle, the only sine ratios are positive. That means the cosine can be negative and the adjacent also can, the tangent can also be negative. So if x is an acute angle, I will just simply say that cos x is 4 over 5. But if x is an obtuse angle, then I will say cos x is equal to, I will introduce minus, which is minus 4 over 5. Please don't forget this. If the angle is an acute angle, we just say x is 4 over 5. Cos x is 4 over 5. But if the angle is an obtuse angle are angles that are greater than 90 but less than 180. It means that your cos x is minus 4 over 5. Okay? So, but in this question, I am going to be working with acute angle. which means that your cos x is 4 over 5. Okay, so if we substitute that, remember we are asked to find 5 into cos, that's x squared. Okay, cos x squared minus 3. That will now give us 5 into our cos x here we just got is 4 over 5 all squared, then everything minus 3. Okay, so that would be 5 times 4 over 5 squared is 16 over 25, then all is minus 3. I think 5 can go in 25 to give us 5. So that's going to be 16 over 5 minus 3, which when we find the LCM, is going to give us 1 over 5 as the answer to that question. So the answer to that question is simply 1 over 5. Wow, nice. Now we see another question here. It says, given that sine x is 5 over 13, and 0 degree, that's degree, is less than x less than 90 degree. Find. Now this statement here is telling us that the angle is an acute angle, because an acute angle is an angle that is between 0 and 90 degrees. So all the trig ratios will be positive. Both sine, cosine, and tangent will be positive because we are dealing with acute angles. But when we are dealing with angles between 90 and 180 degrees, sine will be positive, cos will be negative, tangent will be negative. Please do not forget that. So we are going to apply the same thing here. We have our sine x. This is our right angle triangle. Okay, sine x is opposite. If this is my angle x, okay, the opposite here will be 5 and the hypotenuse will be 13. So the same thing. And so we find the adjacent. Let me use a also for the adjacent. So we can say that 13 squared is equal to 5 squared plus a squared. Okay, so we have 169 is equal to 25, okay, plus a squared. So that means a squared is equal to 169 minus 25. So that means a squared is equal to 169 minus 25 is going to give us 144. Okay, so that means your a is equal to 12. Your a is equal to 12. So it means that to find this, we need to find cos x and we need to find tan x. What is cos x? Cos x is supposed to be adjacent over hypotenuse. So my adjacent is what we just got now, which is 12, okay? Now all over the hypotenuse is 13. Then your tan x is supposed to be opposite over adjacent. So our opposite is already 5, but adjacent is 12, okay? So that is the value for cos x and tan x. The cos x is 12 over 13, while the tan x is 5 over 12. Okay, so now let's solve the question at hand. Let me rub here off quickly. So here we are asked to find cos x minus 2 sine x all over 2 tan x. Okay, so let's see. Our cos x, like we just got now, is 12 over 30 minus 2 times sine x. Sine x is already given 5 over 13. Now everything all over 2 tan x, that means 2 times your tan x is 5 over 12, okay? So that will now give us 12 over 13 minus 2 times 5 here is 10. So this is 10 over 13 divided by here will give us 10 over 12, okay? Now if we find the LCM there, 12 over 13 minus 10 over 13 is going to give us 2 over 13. So we have 2 over 13 divided by 10 over 12, which means 2 over 13 times 12 over 10. Okay, this is good. So if we cancel out, 2 here will be 5, 2 here will be 6. I think 3 can also cancel out. 3 here will be 2 and 3 here will be, okay, that's 13. So nothing can actually cancel out. So let's do that again. Let's do that again. So we have 12 over 13 times 12 over 13 times 12 over 10. Sorry, 2 over 13 times 12 over 10. Okay, and that's going to give us 12 all over 65, which is the answer to that question. Thank you very much.